So, good day guys, I'm Kuizinas, I'm the CTO of Kuizinas Technologies, and we've got some moving parts yet. Still moving? Good, it's in place. And today, probably first of all, what I really want to start with is firstly, could you give the round of applause for the organizers, because they've been doing a great job, 4 days conference with so many talks, so please give a round of applause for the organizers. And I really hope that these applauses won't be the last ones in this topic. But yeah, probably we can start, and basically today we've got the topic, and my main mission was firstly to collect as many catchy words as possible into one topic. So I really succeeded in that, I guess. I just missed the AI part, so that will be for the next year. And yeah, unleashing the power of domain-driven design and AWS with Python microservices. Maybe let's at first start with the reasoning. In the Kuizinas Technologies, we're a development agency, and one of our ways of working with the clients is team augmentation. So we just join the teams, join the internal teams, we become a part of the teams, and in this way, we, one way or another, joined quite a lot of microservice DDD-based projects. And sadly, in majority of places, in majority of cases, they were not very successful. Firstly, they were unmanageable. For example, we even had a case when we joined the microservice-based project, and there was no even a Git repository, right? I'm not even talking about the schemas, how they're operating or like that. In other cases, there was no need for microservices, because once we joined, we just found out that it's a pretty simple application. We can just quickly migrate to the monolith, and a lot of headaches would disappear. So, and in some cases, we did that with the client's approval. Or once we joined, we just found out that it's not a microservice-based project, but it's just a distributed monolith, when all the services are just calling the one database, and in that case, it's not very manageable as well. But based on our experience, we still have some good examples to share, and we really like to share the good examples, and maybe they will influence your choices as well. So yeah, our team once, after joining another microservice-based domain-driven design project, yeah, we're not quite very excited in the majority of cases. But yeah, first of all, maybe let's start with very few components, just to agree, just to be on the same page, that we're talking about the same thing. So domain-driven design. Domain-driven design was basically introduced by Chris Evans back in 2004, something like that, so it's almost 20 years, in the so-called Blue Book. And this book is, pretty hard to read. I tried that, and I successfully failed. It's not a book to read before bedtime, so you have actually, spend work hours for that. And what it's mainly about, it puts the main emphasis on ubiquitous language. Ubiquitous language is, the main term that you would all be talking the same language. Whether you're on the business side, whether you're customer support, whether you're a developer, basically you must be talking the same language in the same terms, even in your code. And another thing is bounded context, the isolation part, that once you're working on one of the domains, one of the services, it's isolated and, it's not being repeated elsewhere. And main thing, modeling everything around the domain. So basically just separating your businesses into separate domains so that they would be responsible for their own logic. Yeah, and actually Wikipedia puts it quite nicely that it's a major software design approach focusing on modeling software to match domain according to input from that domain's experts on the same ubiquitous language. Yeah, I'm not spending much time on that. Microservices, right? It's a pretty common term, but just for us all to be on the same page, it's an architectural approach, first of all. Sometimes it's called even a next generation of service-oriented architecture, but maybe a more modern one, if I can call it so. So basically, there are two main parts on microservices. That it must be a collection of loosely coupled, very important word, loosely coupled services, and reusable ones, so that other services would be able to reuse it whenever they need it. Services can communicate via the agreed protocol, REST, GraphQL, gRPC, you name it. Biggest pros, scalability, reusability. So basically that every single service would be responsible for its business, single business capability. And definitely development, scaling, deployment should be independent, right? there is one more term. I didn't lie in my description. We won't be focusing on the theory, just for us to align. And yeah, serverless. So with the serverless, we can focus on the business, right? Without much thinking about the underlying resources, operating system, scalability, a little bit, but you don't have to focus on that, right? So we have fewer operations, so we can focus on the business. Saving costs when used at the right place at the right time. So this definitely must be highlighted that not at all times, right? We also are Prime Video case, right? And yeah, in AWS we've got tons of services, Lambdas, SQL databases, Kafkas, you name it, EventBridge, tons of services to help us, right? But domain-driven design, AWS serverless, microservices, all the cool words which are used by the cool boys and girls, how do they stick together? How do they work, right? So basically, what I'll be doing in this presentation, I'll be trying to present you one use case, which was truly interesting one. So one of our clients on which we're still working on, Mainhive. What is Mainhive? Mainhive is B2B cloud platform for smart metering. So yeah, IoTs are included, all the devices, various devices, the various manufacturers. So we support various devices like water devices, heat, temperature, CO2, tons of devices. SysT joined on the very first day of a project, so it was 2.5 years ago. I joined from the backend side, and we had our front-end guy setting up the front-end. And just for you to understand the current scope, we've got over 160 GitHub repositories and over 140 Lambdas. This number is constantly growing, so these numbers are from the yesterday. I would need to check today. But what is the main functionality behind the Mainhive? So firstly, data pipelines, and secondly, business intelligence platform. Data pipelines, we discussed with the architect that we don't want to reinvent something, but you know, more commonly it's known ETL or ELT. While we said that we have ETLT, and we have one quite good reason for that. Since we're receiving data from the various manufacturers, from various devices, various kinds of devices, we try to tackle the vendor lock-in problem. And this means that after extracting the data, which comes in the binary format, even every single bit can mean that the device is reporting outage problem, leakage problem, or just sending the normal data. We're trying to transform it at very little so that we could unify the data and to load it as soon as possible into our data lakes. And after that, we're doing the biggest transformations, all the aggregations, and then loading into business intelligence to the Power BI for the dashboards, predictions, and all the other cool stuff. Apart from that, yes, as I mentioned, various providers, device manufacturers, alerting, device. So tons of devices, tons of data coming in and out of the system every day. So yeah, monolith might have been pretty hard in this case. But now let's get down to technicalities, right? Where the most interesting part lays down. The very beginning, how we started this project. So the architect started with the domain-driven design and service-oriented architecture, right? Which we already agreed on upon the terms. And when I interviewed him, I just barely asked him, why? Because all the consultants, for example, I'm following Sam Newman, which is microservice consultant, and he always highlights that all the projects should start from the monolith and then grew into microservice project. So the architect said pretty simply that the business case was already known, so we was able to focus on the technical part. This means we already knew that we will need the loads and we will need to align to the client needs as soon as possible. So domain-driven design allowed us, to quickly create the domain and remove it out of our architecture in the mean of time, right? So just separate from the businesses, and basically all the other platforms would still be working quite nicely. Also, it was agreed to go full AWS Cloud Native. This means take advantage of all the AWS services, Redshift, Glue, Lambda, EventBridge, Kafka, RDS, DynamoDB, all the cool services. Probably we're using the majority of them, apart from the speech and voice and image recognition. But yeah, tons of services being used. And it was agreed to go serverless. And once I joined the project, I had the very first big decision to make. What will be the underlying Python part, right? So there were quite several considerations. So first consideration was fast API, but back at that time, 2.5 years ago, fast API was still steadily growing. So we just thought that whether it's worth to risk it. And then I decided to go full pure Python and take the advantage of the cloud native. So basically not use any framework on the whether it's Django, Flask, well, Django on the Lambda side would be pretty overhead, right? And to focus on the pure Python microservices. And so far it really worked great. We'll come to the Python part later on. And it was also decided to go to put a lot of focus on CI/CD, since we knew that the microservices will evolve at the speed of developers, right? As I mentioned, 160 GitHub repositories. So CI/CD was pretty crucial. So Circle CI really allowed us to do that. So basically, every single service can be deployed, checked, and validated in the matter of up to 2 minutes, maybe at most. And infrastructure as code. So basically, we wanted to automate everything. So Terraforms really allowed us that. And basically, every single service is responsible for its resources, which are defined by the Terraforms. And maybe not so technical thing, but I really want to put more emphasis on that, because we really don't find it very often in projects. Lucy charts, schemas, draw, IO, you name it, really helped us very much. Basically, every feature, every epic, every refactoring starts with the schemas. We just lay down some schemas, we discuss that, whether we approve or not, and then go only to the coding, to the ticketing part, and so on. So Lucy charts really helped us with that. Then Confluence, all the schemas go on to the Confluence one way or another. We've got all the technical agreements over there. I don't know, we even have a section called WTF, really nice section, I really like that. And recordings. Actually, a quite nice thing that after a big refactoring, after a big epic implementation, we just do a presentation for the team so that all the team would be aware what has been done and what needs to be anticipated. And all those recordings are stored in the Confluence as well. So it helps not only the new guys to understand what's the main functionality of that domain, but also for the others in case they missed the meeting. So yeah, cool thing. But now going down to the principle, how we are developing those services, how we started from the day one. Basically, every domain is separated into several services. And even one domain can consist of several services of several GitHub repositories. And we're basically modeling it around the data. So in case we've got this service, let's put it like that, device, right? We've got device table inside one repository that is responsible for this database. And we've got 2 ports to reach this resource. One port is API side, right? In case the frontend needs that. So this port is aware about authorization, how users are working, what permissions must be checked, right? And other port is interface. Interface is for the internal other services usage. So very simply, in case frontend needs devices, it goes via the API port. And in case the other service, like, I don't know, addresses, we need to get a list of devices for this address, we go to service interface via addresses API. So this is the very basic principle that APIs are just wrappers for the API side. And the interface layers are more for data return and data retrieval, so that we won't be calling directly the database, which we definitely don't want to. But principles, examples, maybe go into some actionable, right? Some maybe more from the experience. So we've got here. I really hope that you can see it properly. This is the very basic schema of my one of the features which I had the chance to design. Device import, right? We've got some files from the clients, which clients need to import via the front end. And how would that work with the services, right? With the microservices with the AWS. So firstly, we've got one entity at the top, which is responsible for the aggregation object, right? For the import object, which will take care of the status of the whole import, of the whole file, right? What is the status? How many objects were imported? How many have failed? And basically, we're not loading the whole file into the Lambda because of some limitations on the AWS side, and we still don't want to pay for just loading the file into Lambda. And we reserve a spot inside the S3 bucket, and then frontend directly uploads this file, definitely restricted URL, uploads this file directly to this S3 bucket. Once the file is uploaded, Lambda is being triggered, and this Lambda is responsible for data validation of the file and loading every single row into the database so that we would be able to track every single row of the device of the file as well. After loading that into the database, we just pass all the entries one by one into the queue, and then we've got import action Lambda, which is mainly responsible for knowing how device is being created, right? What other services need to be called, you know, how they are handled. So this Lambda is mainly responsible for this action, and in case it's successfully or unsuccessfully failed, then we're loading all the entries into another queue for the updater part, right? We've got a design, we've got this approved design, and this is how we try to layer it down, try to separate into different services, right? So first service is responsible, as I mentioned, for the whole aggregation object, for the aggregation entry. The second one is responsible for every single row of the file and its status, right? So it's import validator and import updater. And the last service is import action, basically responsible for knowing how this device needs to be imported, how it needs to be created. And basically in this manner, we're separating one domain, the device import domain, into separate services so that it would be easier for us to maintain and separate it into several services. When going through the Python stack, we don't have something spectacular, I would say. Firstly, what really helped us is typing. So the types, not only the input and output of lambdas, but all the data which is going inside the lambda as well when calling other services, when receiving the data. So typing really helped us. We've got type vars, we've got type dicts for sure. Yeah, it really helped us. What else? SQL Alchemy with Alembic, pretty common one for the work with SQL databases. And DynamoDB for the work with DynamoDB, the NoSQL database of the AWS. Yeah, it's quite a nice interface, and really recommend using that in case you're working with the DynamoDB. Then what? Data classes or ORM objects inside the lambdas for the data containers. So in case a service has the database connection, right? It's responsible for some data inside the database, basically working the ORM object. In case the lambda is working as in the example previously on device import action, right? It doesn't have any database. Then we're having data classes as the data containers, pretty simply. Marshmallow for serialization and deserialization. Tried Pydantic v1 didn't see much of the enhancement, but definitely will work out with the v2 version after yesterday's presentation. Botatree, probably de facto standard when working with the AWS, and Casbin. We'll come to the Casbin in a second. So yeah, hints from my side when working with the Python and AWS, from the practical side, which you should be aware of and at least consider it on your existing projects when starting a new one. So as I mentioned before, Casbin. Casbin is an authorization library that supports access control models like access control lists, role-based access controls, attribute-based access controls, basically tons of them. And the cool thing is that it's not language specific, You're not worrying that, at some point it will just suddenly stop the maintainability process and, it will be deprecated. Firstly, probably it's majorly known within Golang's community because it's got over 10,000 of stars for the Golang's implementation, but it's got Java implementation, PHP, JavaScript, Node.js, even Lua, if I'm not mistaken. So tons of languages supported and cross platforms. It supports flexible policy storage. So in case you want to keep those authorization policies, right, for which user, for example, is authorized for which domains, you can keep them in SQL database, which is supported in NoSQL database, in Cassandra, for example. You can keep it also in memory, in file, wherever you want. And probably the main point why I chose this library is because at that point when we implemented authorization, we are not quite sure how it will need to be developed according to the needs from our clients. So the good thing is that access control rules are defined in a configuration file. So it's not Python specific logic. You just define a file with 4 sections, for example. There can be more. And this is how Casbin reads whether it should be authorized or not. So there are 4 sections: request, the parameters which are coming from the requester, policy, which policies must be matched, and matchers, how policies are matched for the requester. So in case all the parameters matches, so then user is authorized. And policy effect is in case multiple policies have been matched. So yeah, in case you're wondering about authorization and role-based accesses, definitely take a look. AWS Cognito. Basically, AWS Cognito takes care of users' data storage and functions. So very good thing about that is you don't need to worry how to store users inside your database, right? Because we all saw some cases when user passwords are being hashed with MD5, right, algorithm, which shouldn't be done, right? Just to agree upon. So basically, you just pass the data to the Cognito, and it takes care of the security, and you're not even possible to control how passwords are being hashed or whether they will be leaked. Sometimes you can take it for granted and say, that okay, I don't need that because I don't know what AWS is doing that, but probably still be safer than you doing something already with the wheel sometimes, right? So basically it takes care of the authorization, so you don't need to reinvent how you'll be implementing JWT authorization or OpenID. Social logins out of the box, and as I mentioned, not worrying about the security. So really helps you to kickstart your project pretty easily without worrying about the functionalities or implementations. AWS X-Ray. AWS X-Ray is traceability service, so tracing service. So basically, in case you're especially using AWS native services, all the actions, all the paths when requests are going through all your services, through the database, through the API gateway, through the S3 bucket, through the Kafka, are monitored. So you can just look at the specific path and trace it back through all the services and even what the scroll query has been launched at the SI. And all the times, how much did it took, how many errors were there during that path. Really great service, and you can just select the period of time for which all the services involved is painted. And later on, I will just show how easy it is to include that in your Python code. So yeah, example service, because yet there were no Python code, right? Very simple service, the interface service, the interface port of the principal schema as I showed before. So we've got it pretty simply. As I mentioned, the X-Ray. So X-Ray in your Lambda is imported just like this. All the AWS services are surely supported, but cool thing is that all the major Python libraries are supported as well, like SQL Alchemy, DynamoDB, and all the other great ones. Logger, definitely. We'll come to that later on a little bit as well. We're initiating DB session. Sadly, I don't have time to maybe go a little bit further to talk about called Lambda starts, Lambda initializations, Lambda invocations. So in case you're interested about that, come back to me after the presentation. And the logic inside the Lambda is just to invoke Lambda's internal function. And that function is basically pretty simple, not much logic. A majority of Lambdas doesn't have very deep logic. So what we do, we just do the data validation. We retrieve needed entry from the database. We use Marshmallow for the serialization, right? And we just return it for the service which has been invoked. Takeaways, right? We will have 3 slides on that, so I'll try to quickly go through them. The probably biggest pro side on microservices DDD is that services are small and act as separate independent projects. So it's really convenient, to focus just on this service without even a slight chance to affect the whole system. Everyone speaks the same business language, as I mentioned, the ubiquitous language. So whether I'm talking with the customer support, whether I'm talking with the data engineer guys, whether I'm talking with the DevOps guys, the language is still the same, right? So this is really great thing. And inside the code as well. Python helps you to focus on logic without any templating, without worrying about how this compiled code will go into the Lambdas. You just do the logic and that's it. And as I mentioned before, useful logs are live servers. I maybe didn't stress this enough during my presentation, but we truly found out that logs are definitely very important, but useful logs, right, for helping your future you are very, very important ones. And when I'm talking about logs, I'm not talking about the ones, the service, the resource has been created, the device has been created. No, it won't help you tomorrow. What will help you tomorrow is that the device has been created with ID this one and all the other related information to this action, right? And especially in case of an error, right? This service has failed because of this, and that with this data. So definitely we had this overhead, we had this headache, and yeah, logs are very useful. Scalability, serverless really helps you to scale, like Lambdas are scaling in a matter of milliseconds, even though Aurora serverless is just scaling like in a matter of several seconds. So truly, serverless helps you with the spikes in case you're not expecting them. Multi-language, maybe multi-language from the programming part, right? So yes, take it with a grain of salt, but yes, on the microservices, as you know, you can just create every single service with different programming language. But in a relatively small teams, you probably don't want to start with that because you will have tons of departments programming different programming languages, and you will need to hire developers for these programming languages. In our case, 90 or maybe even 95% of the services are invited. Independent domain development while communicating only through the interface. Yes, as I mentioned before, you have less risk to impact the whole system. Yes, definitely you still have a chance, but it's more controllable one. Con side, no DB transactions. Since you're communicating through the different lambdas, you can't make a DB transaction on that. You don't want to log the whole database even through different through different service calls. So yes, there are saga patterns when you just schedule how this action will be rolled back through every single service. But on our business case, we are pretty lucky because we don't have so many atomic actions. It's IoT, so we chose eventually consistent pattern so that we're taking care of the main domains and all the other data is eventually consistent. Requires highly skilled professionals? Yes, definitely. With developers who are not only highly experienced, but also taking ownership. Because taking control of whole farm of the microservices can be pretty tricky. So some lead developers must be really experienced. Can be challenging to maintain consistency between services. Yes, as I mentioned, CI/CD helps with that quite a lot. Onboarding new people is more difficult because people tend to firstly try to understand the whole picture, and with microservices with 150 database repositories, this can be pretty difficult. And core refactorings are complex. Yes, especially when you need to block maybe several services, several core services, you need to align the deployments of them. Yes, unit test value. On the monoliths, unit tests have higher value, and the higher value we put now on integration test and acceptance test. And requires a significant investment upfront for the infrastructure, for the CI/CD, for the whole schema pattern. So yes, it really requires quite an investment upfront. Summary, really quickly. As I mentioned, requires really highly skilled, not only the developers, but the architects. So definitely kudos for the architect who is taking care of the whole implementation and maintenance. I would say it's only applicable to projects with complex business logic. In case it's a simple CRUD application, definitely don't start with the microservices. I know, unless there is a very specific business case. Microservice versus monoliths, definitely an eternal discussion, I would say. So I promised to use it only once in my presentation, so I will use it now. It depends, right? So yeah, it really depends, and you must really do quite an investigation before choosing whether monolith or microservices. Not suitable for short-term or indefinite duration projects? Definitely yes. And yeah, Python integrates well with the AWS. All the X-ray, all the support inside AWS Glue, crawlers, event bridge, and so on and so forth, really integrates very nice. And last but not least, commercial part, right? So we're hiring the developers. We've got a variety of projects for the Django Python part. We've got a variety of projects. We've got awesome colleagues, the best ones in town, believe me. And we've got guild meetings. So yeah, be sure to come up to our stand for the remaining part of the day. Meet me there in person. And yeah, thank you for the listening. And probably we don't have time for questions, right?